Welcome back to Elementary Statistics. We are in part 17 today. We are going to be looking at simple probability as we move into the more, I don't want to say difficult, but just a little bit more challenging examples of probability, but this one is going to be pretty simple at first. So just as some observations about events and the likelihood of things happening, in most situations we have a lower likelihood of being able to predict events in the short run, such as predicting cancer survival rates in a population of just 3 people. Okay, so if we're trying to predict whether something is likely to occur, unlikely to occur, if we don't have very many, a large enough sample size or a large enough number of events, or large enough data collected, you could say it's very difficult to predict that, right? 3 people just randomly polled and trying to predict whether they're going to survive cancer is going to be quite difficult to do. In most situations, we have a higher likelihood of being able to predict events in the long run. Predicting cancer survival rates becomes easier as we have more data and as we understand related factors to cancer, such as cancer type, age, etc. So it's just something to consider because it will relate to some of the things we've looked at, like the law of large numbers, etc. Now, probability in general is the likelihood of something happening, such as an event occurring in the long run out of a number of observations of those events. When we state probability as a number, we generally use it like as a fraction. We use a fraction or a percent to represent it. So we like a 50% probability or 1 out of 2 chance in the form of the event divided by the number of possibilities. So if you are kind of into equations, or you like that, or you relate more to that, think of the equation as being the actual specific event divided by the number of possible events. Now, and we'll discuss this in a future video, but I will acknowledge, remember, going back to kind of what we discussed, we are still going under the under the laws of physics here, right? So it is possible that if we, let's say, flip a coin, because the probability of anything happening is, yes, that's true. But if we flip a coin, the probability that the tail magically turns into a head and lands on the head, so then it would be 100% a heads, since it's going to be heads, tails, but the tail changes to a head. We're not looking at those. So the universe could do some bizarre things, but we're not looking at those possibilities. We're still going to be looking at probability governed by the laws of physics. So the probability of flipping a coin on heads is 1 out of 2, as the heads event, if we think of it as that, is 1, and the total number of possibilities is 2. And I know there are some people who will be like, well, what happens if it lands perfectly on its side and it doesn't fall to either side? That's another one of those. Not going to happen. Yes, the probability exists, but we're not going to look at it. And then, of course, the probability of flipping a 2, 3, or 5 with a die is 1 out of 2, as those are 3 possible events out of 6 total possibilities, I should say. So we think about a dice, there's 6 sides. The possibility or probability that we roll either a 2, 3, or 5, that's 3 total events out of 6. It's the same as saying 1 out of 2, right? 3 divided by 6. Okay, or 50%. And again, if we wanted to say 50% in those cases, that would be fine. It's you can state it as a percent or as a fraction. Depending on which homework you do, they may have specifics. So we're going to do some simple exercises. So go ahead and pause the video, complete the exercises, and then we'll go through these. All right, exercise 1. John is playing a game with friends and needs to roll a 5 on the die to win, or roll a 2 to tie the leader of the game. What is the probability that John rolls the die and it lands on 5? So there's 6 total possibilities. We're going with a standard die. There's 6 total possibilities. 5 is 1 possibility, so the answer is 1 out of 6, which I believe is 16.666666, on and on and on. But 1 out of 6, that'll work for this one. Now, what about if he rolls a 2 or a 5? So that's 2 that we're talking about out of a total 6. So 2 divided by 6 is 33%, or you could also say 1 out of 3. 2 divided by 6, or 2 over 6, I should say, on the fraction. Okay. So in the first answer, we have a 1 out of 6 chance. Second, we have a 1 out of 3 chance that he rolls a 2 or a 5. By the way, if we had a separate situation where he rolled the die, let's say on 5, and then we had a different situation and then he rolls a 2, that would be a different exercise, and that would be something that we're going to be looking at in the future, like what would happen if he rolled the die again, I should say. Those are different, but that's something to keep in the back of your mind, because some of the probabilities we're going to be looking at, it's an event will be dependent on another event, etc. All right, exercise 3 here, we have Jack plans to buy a puppy and visits the local pet shop to purchase the puppy. Assuming that Jack has no preference and the store receives puppies randomly, what is the probability that Jack buys a male puppy? So there's a total of 2 possibilities here when it comes to dogs. He can buy male or female puppies, so there's 1 out of 2. So there's a 50% probability that he ends up with a male puppy, since he doesn't have a preference and the store is receiving puppies randomly. Okay, and then of course exercises, let's see, 4 and 5 here. A company offers a random gift to shoppers who buy enough items in their store. Assuming that they only offer either a t-shirt, hat, or keychain as possible gifts, what is the probability that Jessica receives a hat if she qualifies and accepts this random gift? So there's a total of 3 possibilities, and hat would be one of those possibilities. So there's a 1 in 3 chance that she receives a hat. And then what is the probability that she receives either a keychain or a hat? Okay, that would be 2 possibilities out of the 3 possibilities. So there's a 2 in 3 chance that she receives either a keychain or a hat. So those are just some simple exercises that we've done here on simple probability. In the next video, we're going to be progressing. There will probably be quite a few videos over the next few weeks on probability.